Today we will discuss about the bipolar junction transistor, that is the BJT, and subject of the analog electronics. So bipolar junction transistor or BJT, that is the very important device in the field of electronics and communication engineering. And the bipolar junction transistor is a basically three-layer semiconductor device, and main function of BJT as a used as a amplifier device, or that convert the or increase the strength of the weak signal to a level of high level. So BJT as a work for the amplification purpose. So this device consists of either two N and one P type layers of material, or two P and one N type layers of material. So this is the basically three terminal electronics device in which two layers may be N type and one layer may be P type, or two layer may be N type and one layer may be P type. So the former is called an NPN transistor, while the latter is called a PNP transistor. So there are two types of transistor. One is the NPN transistor and second is the PNP transistor. In NPN transistor, there is the two layer of N-type semiconductor and one layer of P-type semiconductor. What in PNP transistor, there are two layer of P-type semiconductor and one layer of N-type semiconductor. So there are two types of BJT or bipolar junction transistor, NPN transistor or PNP transistor. So there are some symbolic representation of the BJT. So first, here in this diagram there is three terminal. First terminal is the emitter, second is the base, and third one is the collector. So this is the NPN transistor representation. Second one is the PNP transistor representation. So in each transistor, following points to be noted here. First one is that there are two junctions, or basically BJT is the two junction device. So transistor can be considered as a two diode connected back to back. So it behave as a like two diode connected back to back. Next one, there are three terminals. That terminals are emitter, second is base, and third one is collector. So in this BJT, the middle section is thin than other. So here in BJT, the middle section is the base region. So base region is the thin as compared to emitter region or collector region. So naming of transistor terminals. Transistor has three sections of doped semiconductors. The section one side is called emitter and the opposite side is called as a collector, what the middle section is called the base. So there are total 3 terminals, or that is the 3 terminal device. So here is the symbol of that is represented by 3 terminal base, emitter and collector. So this is the symbol of transistor, and actual picture of the transistor is also shown here. So there are 3 legs, 1, 2, 3. These are the base, emitter and collectors. So naming of transistor terminals. So first terminal is the emitter. The section of one side that supply carriers is called emitters. That is the called emitters. And emitter is always forward wise with respect to base, so it can supply carriers. Next, for NPN transistor, emitter supply holds to its junction, and but for PNP transistor, emit supply electrons to its junction. So we can also say uh, that in NPN transistor, the emitter supply holds to the junction, and in PNP transistor, emitter supply electrons to the junction. So this is the role of emitter terminal in this BJT device. Next terminal is the collector. So what is the role of collector in BJT? The section on the other side that collect carriers is called collector. So main function of the collector, that is collect the carriers, and that comes from the collector comes from the emitter and base. So the collector is always reverse bias with respect to base. So collector is the always reverse bias condition with respect to base region. So for an NPN transistor, collector receives holes to its junctions. What for the PNP transistor, collector receives electrons to its junction. So carrier uh, collects by the collectors in the different charge. In NPN transistor, collect the charge in the form of holes, and what PNP transistor collector collects the charge in the form of electrons. So this is the function of the collector terminals. Now we discuss about the base terminal, that is the third terminal of the BJT. So the middle section which form two PN junction, emitter and collector, is called base. So this is the middle section of the two PN junctions, that is between emitter and collector. So this is the base terminal. There are some important factors in the BJT device. The transistor has 3 regions named emitter, base and collector. So there are total 3 regions in BJT, or simple we can say as transistor. The base is much thinner than the other region. The width of the base region is thinner as compared to the emitter region and collector region. Emitter is heavily doped, so it can inject large amount of carriers into the waves. So emitter region is the heavily doped, so it can inject large amount of carrier charge into the base. The base is lightly doped, so it can pass most of the carriers to the collectors. So we kept the width of the uh, base region is the small as compared to the other collector region or emitter region, so that it can pass most of the carriers to the collector terminals. And next one is the collector is moderately doped. So there are total three layers or three terminals which have the uh, moderately doped and lightly doped and heavily doped. So emitter is heavily doped, base is lightly doped, and collector is moderately doped. So these are the some important factors about the three layers of the transistors. The junction between emitter and base is called emitter base junction, or that is the emitter diode, and junction between the base and collector is called collector base junction, that is the collector diode. So there are basically in BJT two junction J1 and junction J2. Junction J1 is the uh, between emitter and base, and junction J2 between base and collector. The emitter diode is always forward bias and collector diode is always reverse bias, or we can say that the junction J1 is always in forward bias and junction J2 is in the reverse bias in always. The resistance of emitter diode is very small. So diode have the very small resistance in the case of forward biasing condition, and resistance of collector diode is high because in the case of reverse biasing diode have the high resistance. So in forward case and reverse case diode have the low resistance in forward biasing case, and high resistance in the reverse biasing case. So what is the operation of transistor? So working of NPN transistor, we take here a NPN transistor and explaining the working of this transistor. So in this diagram, there is the NPN transistor, and there are two supply voltage. The supply voltage VEB is the across terminal emitter and base, and supply VCB is the across terminal base and collector. So the supply voltage VEB, in that case, the diode in the case, that case is the forward biasing. What in the applied voltage VCB, in that case, the collector diode in the reverse biasing. So forward bias is applied to emitter base junction. Also we can say that the forward bias is applied to emitter base junction and reverse bias is applied to collector base junction. So the junction here, junction J1 is the forward bias and junction J2 is the reverse bias of the transistor. The forward bias in the emitter base junction cause electrons to move toward the base region. This constitutes current, emitter current IE, and in that case when emitter base junction is forward biasing, in that case electrons to move from toward the base from emitter to base, and that current is the emitter current IE. What as this electron flow toward p-type base, they try to recombine with holes. As base is lightly doped, only few electrons recombine with holes within the base because the uh, uh, width of the base is very thin as compared to emitter and collector. So the in the base region there are very few holes there. So there is very lightly doped few electrons recombine with the holes within the base region, and these recombined electrons constitute small base current. So the base current IB is constitute the remainder electrons cross base and constitute collector current, and in that case remaining electrons cross the base region and constitute collector current in the collector region. So here is the total three types current. One is the emitter current, second one is the base current, and third one is the collector current. So total current IE is equal to sum of the base current and collector current. So we can write in the form of, in this formula, I E equal to IB plus IC. So emitter current is the sum of the base current and collector currents. Now we take the working of PNP transistor, and in this case the forward bias is applied to emitter base junction and reverse bias is applied to collector base junction. The forward bias in the emitter base junction cause holes to move toward the base region from emitter region. This constitute emitter current IE, that is the IE current. As this holes flow toward n-type base and they try to recombine with electrons, as base is lightly doped, only few holes recombine with few electrons within the base. So here the base current is very small due to the very low recombination rate of holes with the electrons in this region. These recombined holes constitute small base current. So base current is very small as compared to emitter current. The remainder holes cross the base and constitute the collector current, and remaining holes cross the base and move into the collector region, and that these holes recombine with the electrons in the collector region and constitute a collector current. This is the large as compared to the base current. So now there are some transistor symbols which can be represented by the different symbols. So in this diagram, first one is the form of layer NPN transistor, and second form of the PNP transistor in the form of layer, and third one is the symbol of the which is represented by the base emitter and collector, that is the NPN transistor symbols, and fourth one is the PNP transistor symbols, that is the represented by that symbols, and there are also three terminals, emitter, base, and current collector. So these are the different BJT or transistor symbols. What is the transistor operating modes? So there are different modes of the transistors. First one is the active mode, and second one is the saturation mode, and third one is the cutoff mode. So there are three modes in the transistor in which transistor operates. First one, active mode. In active mode, base emitter junction is forward wise and base collector junction is reverse wise. So in that case, in active mode, the junction J1 or base emitter junction is forward wise, and junction J2, that is the base collector junction, is the reverse wise. What in saturation mode, the junction J1 base emitter junction is forward wise and junction J2 base collector junction is forward wise. So in that case, both junction in the forward biasing in saturation mode. In third type of mode, cutoff mode, in that case, both junctions are reverse bias or base emitter junction J1 is reverse bias, and also the junction J2 base 2 collector is also reverse bias. So in cutoff mode, the both junctions are reverse bias. So there are three modes of transistor, transistor in which transistor operates. Now there are different transistor connections. So there are three types of basically transistor connections. Transistor can be connected in a circuit in the following three ways. First one is common base, second one is the common emitter, and third one is the common collector. So these are the three connections of transistors in which circuit is can be connected. So what is the common base connection? In common base connections, the base is common between the input signal and output signal. So this is the common base connection. What in common emitter connection? There is the emitter is common between input terminal or input signal to the output signal or output terminal. And also like this common collector, in common collector connection, the collector is common to the input signal to the and output signals, or collector is common between input terminal and output terminal. So there are total 3 transistor connections. So this is the circuit diagram connection of the common base. In this 2 circuit diagrams, one for the NPN transistor and second one is the PNP transistor. We see in this both circuit diagram, the base is the common between input and output. So the common base terminology is derived from the fact that the base is common to both the input and output sides of the configuration. So first figure show common base NPN configuration, and second figure show common base PNP configuration. So this is the connections of the common base of a transistor. Now, what is the current amplification factor alpha in the common base connections? So what is the current amplification factor? The ratio of change in collector current to the change in emitter current at constant collector to base voltage is known as current amplification factor alpha. So alpha in the form of formula alpha equal to change in collector current to change in emitter current at the constant of collector to base voltage. So practical value of the alpha is less than unity, what in the range of 0.9 to 0.99. So this is the value of the uh, current amplification factors. So basically current amplification factor alpha is the change in collector current to change in emitter current at the constant collector to base voltage. So this is the current amplification factor in the common base connection. Next, what is the expression for collector current IC? So total emitter current does not reach the collector terminal because a small portion of its constitute base current. So total emitter current equal to summation of base current and collector current. Also collector diode is reverse bias, so very few minority carriers pass through the collector base junction, that is the reverse bias junction, which actually constitute leakage current, in that case ICBO. So ICBO is the leakage current across the collector to base junction. This current is very low or in the range of microampere or nanoampere or this is also we called as a, that is the leakage current or reverse saturation current. So collector current constitute a portion of emitter current and leakage current ICVO. So IC equal to will be alpha into IC plus IB plus ICVO, and also we can explain IC in the form of alpha on 1 minus alpha into IB plus ICBO upon 1 minus alpha. So this is the collector current in the term of alpha. Alpha is the current amplification factor in the common base connection, and ICBO is the leakage current across the base collector junction. Now we draw the characteristics of common base configuration. So what is the characteristics of common base configuration? So we draw the graph between emitter current versus base to emitter voltage. So at the different collector to base voltage. So we see in this graph, that is the input characteristics of the common base configuration. Here base to emitter voltage versus emitter current characteristic is called the input characteristics. So IE increased rapidly with base to emitter voltage. It means input resistance is very small in this input characteristics of the common base, because here IE emitter current increased rapidly with base to emitter voltage. So it means the input resistance is very small in that case. Here emitter current almost independent of the base to collector voltage. So this is the input characteristics graph for the common base configuration. Now we draw the output characteristics graph for the common base. So we draw the graph between IC versus VCB, or output current versus output voltage. Here output current is the collector current, which have the range in milliampere, and output voltage is the collector to base voltage, that is the in range of voltage volt. So we see in this output characteristics there are total three regions uh, represented, or three regions are represented. First region is cutoff region, and second one is the saturation region, and third one is the active region. So total three regions are shown in this graph. So IC yani so IC or collector current or output current varies linearly with output voltage or base to collector voltage. That is the linearly variation between here current versus voltage only when BBC is very small or base to collector voltage is very small. In that case, I see very linearly. So as base to collector voltage increase, IC become constant as shown in this graph. Next, what is the input and output resistance of common base configuration? So we can find out input and output resistance with the help of this output characteristics of the common base configuration. So what is the input resistance in that case? So input resistance, the ratio of change in emitter base voltage to the change in emitter current is called input resistance. So input resistance Ri equal to change in voltage base to emitter divided by change in emitter current. So this is the input resistance which also can and determine or find out with the help of input characteristics of the common base configuration graph. And the what is the output resistance? So output resistance can also find out with the help of output characteristics of the common base configuration. So what is the output resistance? The ratio of change in collector base voltage to the change in collector current is called output resistance. So output resistance R naught equal to change in base to collector voltage to change in collector current. So these are the uh, formulas of input resistance and output resistance for the common base configuration. Next, we come on the common emitter connection. That is the second type connection of the BJT or second configuration of the BJT, that is the common emitter. So common emitter terminology is derived from the fact that emitter is common to the both input and output side of the configuration. So in common emitter connection, the emitter is the common between input and output side of the configuration. So in the first circuit diagram, there is the NPN type transistor emitter, common emitter connections, and second is the PNP type common emitter connections. In first figure, common emitter NPN configuration, and second figure show the common emitter PNP configuration. So emitter is the common between these two circuit diagram between the input and output side of the configuration. So this is the circuit diagram of the common emitter connections configurations. So in common emitter connection, base current amplification factors. So what is the base current amplification factor beta? In common emitter connection, input current is base current and output current is the collector current. So in common emitter connection, here the input current is the base current and output current is the collector current. So the ratio of change in collector current to the change in base current is known as the base current amplification factor or amplification factor beta equal to change in collector current to change in base current or change in also output current to change in input current. So the beta is the change of output current to change in input current. So this is the ratio of the change in collector current to change in base current. This is the base current amplification factor beta. Normally, only 5% of emitter current flow to base. Only 5% emitter current flow to base. So amplification factor is greater than 20. The range of vary from 20 to 500. So this is the value of the base current amplification factor, which is vary from 20 to 500. Next, what is the relation between alpha and beta? So we can find out the relation between beta and alpha. So we know that what is the beta? Beta equal to change in IC to change in IB or change in collector current to change in base current, and also alpha equal to change in output current IC and change in input current IE. So we can also write the beta as beta equal to change in IC divided by change in IB upon change in IE divided by change in IE minus change in IC upon change in IE, and also simplify this and beta equal to alpha on 1 minus alpha. So beta equal to alpha on 1 minus alpha. Also IE equal to IB plus IC. This is also emitter current. And we write down this equation like this. Change in IE equal to change in IB change in IC. And also we write down this change in IB equal to change in IE minus change in IC. So beta equal to change in IC upon change in IE minus change in IC. So we can find out the beta in the form of alpha. So this is the relation between the beta and alpha. Beta equal to alpha upon 1 minus alpha. So this is the relation between alpha and beta. Next, expression for collector current IC. So we know that the IC equal to alpha IE plus ICBO, and also IE equal to IB plus IC, and also IE equal to IB plus alpha IE plus ICBO, and we can also write this IE 1 minus alpha equal to IB plus ICBO, and also we have IE equal to IB upon 1 minus alpha plus ICBO upon 1 minus alpha, and IC equal to 1 plus beta IB plus 1 plus beta ICBO. So this is the expression for the collector current or the output current. So these are the two reference books for this topics. First one is the electronics device and circuit by the Millman and Halkias, and second was the electron fundamentals, which is the by the Wells. There are some multi-choice questions related to the BJT. These are very important and interesting questions. So thank you very much.